My name is Muhammad Faiz Safwan bin Anwar. Today I am going to talk about Electric and Electronic Chapter 2. For the first subtopic is Ohm's Law. What is meant by Ohm's Law is Ohm's Law states that electric current is proportional to voltage and inversely proportional to resistance. What it meant is I is equal to V over R. So what I meant by current is proportional to voltage and inversely proportional to resistance, this is what I meant. So I is for current, V is for voltage, and R is for resistance. We can also write by V equals to IR, or we can also write R is equals to V over I. And when we want to find voltage, we use this, and we want to find resistance, we use this. One example for Ohm's Law example question is the current passing through a resistor is 0.01 ampere when the voltage across the same resistor is 5 volt. What current passes through the resistor when the voltage across it is 7.5 volt? So firstly we have to find the resistance. So we use V equals to IR, or we can also use R equals to I over V over I, and then we use the information given to find the R resistance. So then what current passes through this resistor when the voltage across it is 7.5 volt. So the volt changes from 5 to 7.5, and then we use I equals to V over R to find the current. We use 7.5 volt, and then the resistance we get from the previous answer, okay, and then find the current. So the current is 0.015 ampere. That's all. Thank you.
Assalamualaikum and good day everyone. My name is Najwa binti Muslim, and today I'm gonna explain to you guys about the definition of branches, loops, and nodes in electrical circuit. So let us check it out. Branches in electrical circuit. In electric, branch is a representative of a single circuit element such as voltage source and resistor. This is an example of branch in a circuit. As we can see, this circuit has 3 resistors and 2 voltage source. Hence, there are 5 branches in this circuit that consist of resistors and voltage source. The next one is node. Node is defined as a point in a network where 2 or more elements are connected. Let's analyze this circuit. As you can see, that is the first node which connects the first voltage source with the first resistor. The second node is connecting the 3 resistors together. The third node is at the right hand side part which connects the second resistor and the voltage source. The last node is at the bottom which connects 2 voltage source and 1 resistor in the middle. Thus, this circuit is contained of 4 nodes. Let's move on to the next part, which is a loop. Loop is defined as any closed path in the electrical circuit. If you can see this circuit, there are 3 loops. The first loop is started with node 1 and moved to node 2 and moved to node 4 and back to node 1. The second loop is started with node number 2, moved to node 3, and next moved to node 4 and back to node 2. The last loop is the outermost loop that connect by node 1 to node 2 and move to node 3. Next connected at node 4 and lastly back to node 1. So basically, this circuit is consists of 3 loops. I hope all of you can understand the explanation of this topic, which is the definition of branches, loops, and nodes in a circuit. That's all from me. Thank you.
Hi, I am Yasmin, and today I will explain about Kirchhoff law. Kirchhoff law is commonly used in circuit analysis. There are two types of Kirchhoff law. One is the Kirchhoff voltage law, and second is Kirchhoff current law. As we can see, Kirchhoff voltage law, the total of voltage will be equals to 0, and Kirchhoff current law, the total current in is equals to the total current out. Now, let's move on to the definitions of both laws. The definitions of Kirchhoff voltage law is the algebraic sum of the voltage in the closed loop is equal to 0. For Kirchhoff current law, the total current entering the junction is equals to the current leaving the junction. For some insight of the circuit, these are few examples of Kirchhoff current and voltage law circuit. I hope with all the information that I have provided for Kirchhoff laws, this will help you in solving the problems in circuit analysis. With that, thank you.
Okay, hi and Assalamualaikum. My name is Muhammad Haris bin Osman, and I will be the fourth speaker in this video. So, I will be explaining about voltage and current division. Now, before we learn about voltage and current division, we must know the basics and the fundamental laws such as the Kirchhoff voltage law and the Kirchhoff's current law. Besides that, we need to know that parallel circuit acts as a current divider as the current divides in all the branches in the circuit because the voltage remains same in parallel. So it's vice versa in series. So if it's in a series circuit, the series circuit acts as a voltage divider as the voltage divides in all the branches in the circuit because current remains the same in series. Alright, so from the two laws, which is Kirchhoff's voltage law and Ohm's law, we can come up with another law, another formula for voltage divider. So as you can see, Kirchhoff's voltage law states that in a closed loop, the total voltages must be equal to 0. So as we can see, negative V in plus V1 plus V2 equals to 0. As well for Ohm's law, V equals to IR. So as we can see, from those two formulas, we can come up with a formula for voltage dividers, which is V1 equals to R1 over R total times V in, which is here. The voltage associated with one resistor in a chain of multiple resistors in series is Vn equals to, in bracket, Rn over R total, close bracket, V total, where V total is the total of the voltages applied across the resistors, Rn is the value of the resistor, R total is the total resistors, and Vn is the voltage drop across the resistor. Moving on. The percentage of the total voltage associated with a particular resistor is equal to the percentage that resistor contributed to the equivalent resistance. The largest value resistor has the largest voltage. Alright, so if we take a look at example 1, we need to find V1, the voltage across R1, and V2, the voltage across R2. Alright, So before anything, we must know that according to Kirchhoff's voltage law, V1 plus V2 should equals to V total. Alright, so that's what we need to know. So voltage across R1 is V1 equals to R1 over R total times V total. So we just have to substitute in the values and we'll get our V1. And for R2, for V2 is the same, R2 over R total times V total. We substitute in the values. Since we already know all the values, we will get our V2. So if you want to check our answers, it's very simple. Since we already know the Kirchhoff's voltage law, V1 plus V2 should be equals to 20 sine in bracket 377t. Alright, so for the application, the voltage divider is only used where the voltage is regulated by dropping a particular voltage in a circuit. This is mainly used in such systems where energy efficiency is not necessary. Voltage dividers are mostly commonly used in potentiometers. Alright, so moving on to... Okay, so before we move on to current division, you must know the symbol for parallel resistors. So to make writing simpler, we use a symbol to indicate that a certain set of resistors are in parallel. Here we could write R1 double bar R2 double bar R3 to show that R1 and R2 and R3 are in parallel. Alright, so just like in voltage division, we can do the same in current division, where we use Kirchhoff's current law instead of Kirchhoff's voltage law and Ohm's law. So Kirchhoff's current law states that the total current entering a node must be equals to the total current exiting the node. For example, I in equals to I out. So as we can see here, negative I in plus I1 plus I2 plus I3 is equals to 0. And Ohm's law is V equals to IR. So here is the formula for current division. So R2 double bar R3 over R1 plus R2 double bar R3 times I total, or I source, and so on and so forth. So the best way to calculate such circuits is that we can reduce the number of resistors in parallel from 3 to 2 by using an equivalent resistor. Meaning, if we want, we can combine R2 and R3 to make it R equivalent, REQ. So there will be two parallel circuits, such like this, where R equivalent equals to R2 double bar R3. So the formula will be R2 times R3 over R2 plus R3. So if you want to find the I1, it equals to R equivalent over R1 plus R equivalent times I source. So in current division, the current associated with one resistor in parallel with one another resistor is I1 equals to R2 over R1 plus R2 times I total. The current associated with one resistor, Rm, in parallel with two or more resistor is Im equals to R equivalent over Rm times I total. So the first formula, we can only use it if there's only two resistors. We cannot use it if there's three or two or more. If there's two or more resistors, we must use the second formula. The first resistor is only a special formula if there's less than two resistors. Alright, so in current division, the largest value resistor has the smallest amount of current flowing through it. Alright, so if you take a look at example 3, we must find the currents I1, I2 and I3 to the circuit to the right. So first of all, we must get our R equivalent, our total R. So since we already know R1 is 200 ohms, R2 is 400 ohms, R3 is 600 ohms, we can calculate it. So I source over 200, I source over 400, I source over 600 to the power of -1, which is inverse, we get 109 ohms. So by using the formula I1, to find I1, it's 109 ohms, which is the R equivalent, over R1 times I in. So that will get us 2.18. So it's the same with I2, R equivalent over R2 times I in will get I2, and it's the same for I3. And if you want to check for your answer, it's very simple. You just use Kirchhoff's current law, which is I in equals to I out. Alright, so in summary, the equations used to calculate the voltage across a specific resistor in a set of resistors in series are Vn in bracket Rn over R equivalent times V total, and the equation used to calculate the current flowing through a specific resistor Rm in a set of resistors in parallel R, Im equals to R equivalent over Rm times I total. So that would be it. And I would just like to share what is the purpose of voltage rule, since I missed that out just now. The purpose of voltage rule is that when there's two or more resistors connected in a series, by using voltage divider rule, we can calculate the voltage drop across each resistor. So thank you, and I'll pass you on to the next speaker, which is Muhammad Ifwat.
Hi, my name is Muhammad Ifwat bin Ismail. I want to show you about the topic delta Y conversions. So, delta Y. Many circuits can be simplified using three terminal equivalent networks. These are of the type Y or T and delta or pi networks, as the diagram shown below. So this is the formula of delta to Y conversion. Each resistor in the Y network is the product of the resistors in the two adjacent branches, divided by the sum of the three resistors. Next, this is the formula of Y to delta conversion. Each resistor in the delta network is the sum of all possible products of Y resistors taken two at a time, divided by the opposite resistor. So, I will show you the example of the question. Find the equivalent resistance between A and B in the given network. I will show you the solution. So firstly, for the given network, we can easily determine the value of equivalent resistance RAB through Y delta conversion. We have to follow the diagram. So, previous network can also be represented as below. Now, I am going to solve this network by using delta to Y conversion as shown in the figure given below. For the value of new Y connected resistance are finding through direct formula of delta to Y conversion as shown below. So, we just put the value into the formula. So we will get RA, RB, and RC. Then we continue. After you get RA, RB and RC, the circuit change to Y conversion form. Next, it's formed to parallel circuit. So to find the total R in parallel, you need to use the R total formula. Then you will get the value. So it formed in series circuit. Then you will get the final answer of R equivalent or RAB, which R1 plus R2 plus R3. Then you get the answer is 9.65 ohm. So this is the conclusion. The while data conversion is required in three-phase AC systems to simplify the circuits and ease their analysis. If a three-phase supply or a three-phase load is connected in delta, it can be transformed into an equivalent Y-connected supply or load. After the analysis, the results are converted back into their original data equivalent.